So today we're going to look at loans, and one thing that you should notice here is that the first, or the formula here, right, is the same as our payout annuity. All right. All right. Now the reason for that is that it's technically the same type of transaction, right? It's just in this case we're paying a bank, for example, probably for a loan instead of withdrawing on a regular basis. But it's the same idea, right? If you recall the payout annuity, you had this lump sum and you withdraw on a regular basis, whether that be monthly, right, or quarterly, right? But there is a fixed amount to begin with, and then when you withdraw, that amount that is still left in the bank or wherever it is that you have your account, it is still earning interest. So that's the same concept with a loan, right? You take out a loan, right, and then you pay down a monthly payment. Some of that goes to interest, right? Some of that goes to the principal balance, right? But that initial amount for the loan, right, it starts off in the beginning, and then you start paying it down, right, till eventually it reaches zero. So it's the same kind of concept as a payout annuity, right? But we just kind of rephrase our questions. Okay, so as we work through these problems, right, you always want to ask yourself, all right, which formula do I use? Because as of now, we have adding to our loans, we had the compound interest, annuity, the payout annuity, right? And now this loan formula, right? So when you start this problem here, you always want to ask yourself, here. All right. Okay, so it's going to be a compound interest annuity, a payout annuity, or a loan, right? And you want to ask yourself to know which one you're going to use. Is it one deposit? Is it many deposits? Is it many withdrawals, or is it many payments? Right? And depending on what the answer to that is going to tell you which formula you're going to use. All right, so here, when we look at, all right, we have one deposit, it's always going to be compound interest. Many deposits, it'll be an annuity, right? Think of a savings account, right? Payout annuity, when you kind of withdraw, but the money that is still left over is still earning interest. And then your loans, right? That would be many payments. All right, and again, keep in mind these two down here, you're going to use the same formula. Right, the only thing different here is that the way that we phrase it, right? In terms of a loan, the P naught is the balance of the account in the beginning, right? How much you take out in terms of the loan, all right? As opposed to the payout annuity, as opposed to the loan, the loan, D is going to be the loan payment, and then R, K, and N are the same as before. Interest rate, K is the number of compounding periods, N is the length of the loan. Okay, all right, so let's take a look at a question. Okay, so in this example, Sonia bought $3,000 of new furniture on credit. Because her credit score isn't very good, the store is charging her a fairly high interest rate on the loan, 16%. If she agreed to pay off the furniture over 2 years, how much will she have to pay each month? All right, so let's take a look here. So again, pay each month, right? So there we think many payments. So right away we think the loan formula, right? So let me write the loan formula up here. P0 D over K, 1 minus NK, and then R. Okay. All right. So that is going to be the formula that we're going to be using. And notice here, what do we know? We know how much the furniture costs, so the initial amount of the loan. All right, so we know that P0 is going to be $3,000. All right. And then we know the interest rate, right? We see that as a percentage. Okay. All right, the interest rate is 16%. And then we know that she agreed to pay off the furniture in 2 years, right? So that means that here, 2 years, so N is going to be 2. All right, and we also know K, the payments are each month, so K is going to be 12, right? 2 years and 12 for monthly. All right, so the one thing that is missing here is how much is Sonia going to be paying each month. All right, okay. So here, let's take a look. So D is our unknown. All right. Okay. All right, so now let's take a look at our formula here. So plugging in the values that we do know. So we have 3,000 for the P0. D is my unknown. 1 minus, open up a set of parentheses, 1 plus the rate, which is 0.16 over K, which is 12. And then in our exponent, -2 times K. And then close the set of parentheses. And then in the denominator, we'll have R over K, which is 0.16 over 12. Okay. All right, so here is the setup, right? First thing is, right, the kind of the most important part here to get us on the right track to begin with is to identify the correct formula, which we did here. We saw many payments, right? So referring back to our table here, many payments says loan, right? So we have our loan formula. We identify all the different pieces, right? The initial amount of the loan, the rate, the number of times I'm going to pay this loan, in this case, monthly over 2 years. The one thing I don't know is how much my monthly payment is going to be if I want to pay this off in 2 years. Okay, and that is what I'm set to calculate. All right, so now once we have everything set up in our formula here, let's start kind of simplifying some things. All right, so I'm going to, in my calculator, I'm going to calculate what 0.16 divided by 12 is. All right, so here, let me start doing some calculations here. So we'll get still 3,000 on the left side. And then over here, I want to replace this by 3. All right. Okay, so again, 4 decimal places, it's repeating. 4 or 5 should be good enough for our calculations. All right, then in the numerator, we're going to have D 1 minus 1.0133 raised to the -24. Okay. And again, here, all I did was I calculated 0.16 divided by 12, and then I added it to 1. All right, so again, so far, I'm just kind of simplifying these calculations here, and then -2 times 12 is -20. All right, so the next thing I'm going to do is I'm going to calculate whatever this is inside the parentheses. All right, so let me bring up my calculator here. All right, so let me turn this on. Quit. Clear. And again, what I'm after is 1 minus 1.0113. I'm going to raise that to the negative 24th power. Okay, and then I'll hit enter, and I get this 0.2364. 64, I guess, if we're rounding to the proper place value. So let me make note of it, 0.2364. Let me go back to my notes. All right, and again, that is the whole value inside the parentheses here. So we have here 0.2364 times the value d, which is our unknown, over 0.0133. All right. We got point divided, no. So here, I got 0.16. So in the parentheses, what we're seeing here, this value came from the parentheses up top here. It came from 1 plus 0.16 over 12. And that's where the 1.0133 came. Okay, so it's essentially the denominator plus 1, and that's what's in my parentheses up there. Okay? All right. No problem. Okay. All right. So again, right, we want to do this one step at a time. All right. So now the next step is I'm going to perform that division there on the right side. I'm going to take 0.2364 divided by 0.0133. All right. So here, we'll do that in my calculator. So 0.2364 divided by 0.0133. And then here we get, oops. The left is still 3,000. And then these two numbers divided, we get 17,774. And I'll keep it consistent here. I've been doing 4 place values. All right. Okay. All right. And now we're finally at the step where I can solve for B by doing, solve for D by doing one last thing. And in this case, that is dividing both sides. Okay. Okay, and then we see here, when we divide this, on the right side, that quantity simplifies to 1. So we just get left with D. And on the left side, I'll take 3,000. And I'll divide by 77,744. And we get 168. Thank you, Theodore. Dollars. And then the final result, since we are dealing with money, I'll just use 2 decimal places, right? Since we're dealing with money. Since answer is money. All right. So Sonia would have to pay this amount over 2 years in order to pay off her $3,000 loan at 16% yearly interest rate. Okay, any questions on this example here? Excuse me. All right. Now, one thing to notice here, we did the calculation is you kind of want to ask yourself, how much did that $3,000 loan actually wind up costing, right? And it's not $3,000, right? It actually, considering with this high interest rate, it actually is more than 3,000, right? If we think, okay, if we paid $168.78 over 2 years, how much money did I actually wind up paying? Now, that's not part of our question, but let's just kind of answer that just so we could see, how those interest rates, when they're pretty high, how much you actually wind up paying, right? So now let's say we wanted to ask ourselves, all right, here, if we have time, we can go over it at the end, all right? So here, we want to ask ourselves how much does Sony wind up paying for the furniture? The question. Right. Now, one thing to keep in mind, it is actually not $3,000, right? That was the loan, right? The loan was $3,000, all right? But let's see, how would I answer that question? Well, if I know how much she paid per month, right? That was 168. That's what I calculated here. All right. And how many months did she wind up paying this for? It was for 2 years, so 24 months, right? So we can actually calculate this by performing 24 for the 2 years of the life of the loan times how much she actually paid per month. 70. Okay, and if I do that calculation, we get the furniture actually wound up costing her $4,000, $4,050 with 72 cents. So over those 2 years, she wound up paying about $1,000, $1,050 in just strictly interest. All right. Okay. All right. Any questions on this example here? Yeah, no. Yeah. So watch out with those high interest rates, right? So that's 16%. Okay. All right. Okay, let's see here. All right, any questions? Doing okay? All right, so let's take a look at this, right? So in this example, it says Joel is considering putting a $1,000 laptop purchase on his credit card, which has an interest rate of 12% compounded monthly. How long will it take him to pay off the purchase if he makes payments of $30 a month? All right, now these are one of the, it looks like how long. So again, right, payments, multiple payments, right? So when we see that right away, you want to think loan, right? So when you see here, multiple payments, right away you want to think to yourself, oh, I'm going to be using the loan formula, right? So let me write the formula up here. R over K to the negative nk all over r to the k. All right. And just looking at kind of the wording, how long, it looks like I'm going to be solving for n. All right, so now I know when, from last time, when we have a variable that is in our, exponent, we're going to be using a logarithm. Yeah, so a logarithm is going to come into play, right? So always kind of keep that in mind when we need to solve for n, right? That's going to involve, we're going to use the log function. Okay, all right. So we've identified that we need to solve for n. So now let's look at, well, what are all the other pieces of information? All right, so putting a $1,000 laptop purchase. Okay, so here, that means that is our initial amount. We start off with $1,000, right? Interest rate is 12%. K is 12, right? Monthly. All right, and then the payment is $30 a month. All right, and again, last thing missing here is n, which I don't know. All right. So again, right, I would recommend when you work through these problems, right, just kind of list out like I'm doing right now, where you have the just kind of listing out the variables, right, what you know and what you don't know, right? You should always not know one of them, right? So we're not usually, for the most part, we'll be solving for one of the variables. So it would just be one that is unknown, right? And if it's going to be n that is unknown, excuse me, then it is going to involve the use of a logarithm. Okay, so now let's plug in to our formula. So we see here 1,000. That's going to be equal to 1 plus parentheses 1. R is 0.12 over 12, and then negative 12K all over okay. And then from here, I'm going to start doing the calculations. I'll start with the, again, one step at a time. I'll start with the denominator. So I'll put in my calculator 0.12 divided by 12. So here. So we'll do that one first. So we'll do 0.12 divided by 12. And there we get 0.01. Okay, so going back to my notes. So we get here 0.01. We still have 1,000 on the left, right? And oops, I'm missing one thing from my formula. Sorry, I forgot the D, the monthly payment. I didn't write it there either. So 30, sorry about that. So again, that comes from our formula, right? D. Okay, so 30, 1 plus, and again, I know what 0.12 divided by 12, I just did that calculation. That was 0.01, so I'll go ahead and add it to 1, and we get 1.01 to the negative, oh my God, this should be 12n. Sorry about that. I'm sorry. Oh, God. All right, fine. It's minus. Thank you. Monday. Still a little groggy here. Okay. Thank you, Alexandria. Yep, that should be minus. Okay. All right. Let me compose myself here, wake up a little bit. Okay, so I think we're all on the, well, me, I think I'm on the right track now. Okay. All right. Any questions so far? So far this is same as the previous problem. Here is where we're going to take a different approach here because we're solving for a different variable. Okay. So we want to solve for n. Now n is all the way in here, right? So I need a few steps before I can get to n. Right now the first step is going to be multiplying both sides by the denominator here, right? So now it just becomes a matter of solving an equation. So I'm going to multiply by 0.01. Remember, right, when dealing with fractions, I'm multiplying. And again, if I do something on one side of the equation, make sure you do it to the other side. All right. I do it as a fraction just so you can see here that what's going to happen here is that this is going to reduce to 1. Right. So on the left side, excuse me, on the right side, we're going to get 30. And now the denominator simplifies to 1. So I don't have, well, I have a denominator of 1, so I can actually, don't need to write it. So I eliminated essentially the fraction part of this. And then here on the left, I'm going to go ahead and multiply 1,000 times 0.01. I'll show you guys that. So we get 1,000 times 0.01. Hit enter, and we get 10. All right. Any questions so far? All right. Again, getting closer and closer to our goal of wanting to solve for n. Right. So the next step is that 30 in front of the parentheses. Right. We go one step at a time. Right. Working out till we get all the way in. Correct. -1. Right. From the formula. 1 minus whatever that quantity in the parentheses is. Okay. Okay. All right. So now the next step here is I want to divide both sides of the equation by 30. All right. And again, the reason for that is this is going to reduce to 1. And now I get even closer to solving to n. All right. And on the left side of the equation, I get 10 over 30, which is 1/3, which is using an approximation. All right. And I'll keep it consistent. Right. I go 4 decimal places until the end, and then I'll round to the appropriate value depending if I'm dealing with money or time. All right. Okay. All right. Again, right, one step at a time. Each step of the way, we're getting a bit closer to our solution here. So here I'll subtract 1 from both sides. Right. And then we'll get 0.333 minus 1. And this is all right. And then one last thing before I introduce a logarithm, I'm going to multiply both sides by a -1 just to have a positive coefficient. So here, multiply by -1, and that gives me 0.6667. Let me redo that here. 1.01 to the -12n. Okay. All right. Okay. Any questions so far? All right. So then from here, now we're at the point where we have we can't divide or multiply anything else, right? Because the n is in the exponent. So here is where we have to get the variable outside of the exponent. All right. So notice here, in working through these when we're solving for n, right, we reach this point where all the techniques that I've learned to solve equations, right, I've already exhausted here, right? So now it's like, all right, I need to get that exponent, or I need to get the variable out of the exponent, right? And then the way to do that is by taking the logarithm of both sides, right? So what I'm going to do from here is we're going to take the log of both sides of the equation. All right. Treat it like an operator, right? Like you divide both sides, right? You can take the log as long as you do it to both sides of the equation. Okay, now what we want to recall here is that, okay, here I need one very special property of the logarithm that allows the solution for n, for me to find the solution for n right away. Right? So I need to remember that when I have an exponent in a logarithm, one of the properties of log is you can take that exponent and write it as a coefficient. So I'm going to move my work up here where I have more space here. Okay, and I'm going to rewrite the part on the left remains the same, right? So we have log and what's going to change here is the -12n comes out in front. Go outside the lines and the copy gets all weird. Let me try that again. Okay, so we get something like that, right? And again, here, all I did was I applied that very special property of logarithms that allows me to take the exponent and write it as a coefficient. Okay, any questions on that part? Okay. And now I can apply the same techniques that I had before, right? Of division. So remember, what is the goal? The goal is to solve for n. All right, so I need to solve for this variable here. All right, and I'm really close now, right? So now what do we do from here? I want to divide both sides by negative 12 log .01 and then negative 12 log of 1.01. Okay. And then from here, let's take a look. So I'll bring my calculator up. Okay, and then I'll plug exactly like I see it there. So I'm going to say, all right, log of 0.6667. Oops, what did I do? Log of 0.6667. Close my parentheses. And then divide by, open up a set of parentheses there and put negative 12 log of 1.01. All right, and then I'll close my set of parentheses. Okay, now it's important here. Well, let me just calculate this for now. Okay, okay. Okay. All right, and then I'll hit enter. And we get 3.39. Now we're dealing with years, so we'll just say we'll call it n to be about 3.4. Right, so we'll say, okay, n is about 3.4. Let me switch over. Let's say n here. Okay. All right. So it'll take about almost 3.5 years to pay for this $1,000 laptop if he pays $30 per month. Okay. Any questions on this part here? No, it's always one log. We usually won't solve for K. They'll usually tell us how often payments are made or withdrawals are made. All right, so for the most part, we would always solve for n for the time, and that would require a logarithm. Okay. Yes, it will be. Okay. Now, a couple of things I want you guys to watch out for and just be careful as you are using your calculators here. All right, so you should be seeing my calculator here is the way you input these. All right, so if you notice here that if I didn't have the set of parentheses when I hit division, you don't get the right answer there, right? And again, the reason for that is your calculator is not very smart. It's very fast. It can do operations very fast, but unless you tell it to do exactly what you want it to do, it will not perform the correct calculation. Okay. All right. So yeah, so you have to be kind of careful there. as you input it, right? It wants the negative sign, and notice there's two, there's a negative and there's a minus subtraction sign, and those are two separate things, right? So you have to be very specific to tell it exactly what it is that you want, okay? All right, now, another way you could input this, if you could do that, second, let me bring that up, is if you didn't put a parentheses here, the reason that you get the wrong answer is it follows the order of operation, right? And again, order of operations is parentheses, exponents. Now, one thing that, I mean, I'm sure everybody always recalls PEMDAS, right? The problem with that is it's multiplication and division, right? You take both of those as the same and you work from left to right. And you take addition and subtraction as essentially the same operation, but you work for them from left to right. Now, the reason you get the wrong answer in dropping the parentheses is what that operation does. It divides by -12, but then it multiplies by the logarithm. It interprets it as a multiplication. And the way I change that is by putting the parentheses, because now it does the denominator first, and then the overall larger division. Now you could also do this, and since you want to divide by both of those, you can hit insert and then hit divide again. And now notice we're back at the same value. Okay, so be careful as you multiply these, right? Remember, calculator, not very smart, but very, very fast. You just need to tell it what it is exactly that you need to calculate, all right, by using parentheses, right, in proper notation. All right, any questions? Okay. Okay, so now let's go back to our notes here. Okay, so let's look here now. Let's same as we did with the previous one. Let's take a look at how much did that $1,000 laptop actually cost. What was the actual cost of the laptop? Okay. All right. Now it's not 1,000, right? That was the retail cost, but we had to pay some interest here. So let's try to figure out how many months 3.4 years is, right? Now I know how many months 3 years is, right? 3 years is equal to 12 times 3, 36 months. Now what is 0.4 years? 0.4 years, and the way you can calculate that is just take 0.4 and multiply that by 12. Right, months in a year. Now, if I do that calculation, I get a decimal, and I'm going to round up since I don't want to deal with decimal months. So I'm going to say that's about 5 months. All right, so I wind up paying for this laptop for a total of, what is this, 36 plus 5, 41 months of payments. Okay, and let's see how much is 41. How much were these payments again? $30. So 41 times 30, that is $1,230. All right. Okay. Okay, so you wind up paying about $230 in interest on this $1,000 loan, right? Over a little over 3 years. Okay, and again, clearly, if you paid it off, if you paid more for your monthly payment, then you would, excuse me, you would wind up paying less interest. Okay, any questions here on this example? Yeah, correct. We answered the question. I think I will sometimes ask you that. It's just good to see just kind of how much you're actually paying for something. All right. Okay. If there are no questions, I actually don't want to get into the next part of this loan, so I will take. I think Grecia had a question for, or Giselle. Sorry, I don't had a homework question. Do you have the page number off the top of your head here? Thank you, 223.